Today we are going to solve three variable systems. Now here's a system of equations that is in three variables. We've got x, y, and a z. And in order to solve for three variables, we need three equations, which we have here, 1, 2, and 3. Now what I want you to notice about this is that each equation has one less variable than the equation above. And it forms this kind of staircase in a way, which makes it very convenient to solve. And we solve these using back substitution. So here's how this works. We already have that z equals -2 over here. So we're going to substitute this value. We're going to have 6y minus 5 times -2 equals -8. We solve, and y is -3. So now we have a value for z and a value for y. We can use this first equation to solve for x. So we have 4x minus 3, y is now -3, minus 2z, which is now -2, equals 21. So x is equal to 2. And our last step is to write our solution, which would be our x, our y, and our z, which would be 2, -3, and then -2. And we can check this if we want by substituting each of the values into each of the three equations. Now here's a system that's just a little bit different. We still have three variables and three equations, but this is not in the same step formation like the previous problem we solved. Now just for organizational purposes, I suggest that you do this in your notebook before you write this in your organizer. So here we go. We first have to get rid of these x's and the y. If we get rid of these three terms, then we've got that step formation. And we can eliminate them in any order. I just prefer to do this first, then this, and then that one. And what I do is I kind of make a table over here. And I'm going to circle the term I want to eliminate. And before I do that, I'm going to rewrite the two equations that I'm going to leave alone. I'm going to leave a space. We've got 2x minus 5y plus 5z equals 17. And we'll leave a space for our new second equation that does not have this x here. Now we have to decide how to eliminate the x. We use the same techniques we did previously with two variables and elimination. We're going to add equations together. And it looks very convenient to add this equation to this equation because then those x's will cancel out. So I'm going to do that on the side here. I'm going to say, I'm going to rewrite the first, rewrite the second, there's no z in there, and add them together. The x's eliminate. We're left with 1y plus 3z equals 5. And I'm going to take that equation and write it in there so that we've got y plus 3z equals 5. So we have our very first step. Now we need to eliminate the 2x. We're going to get rid of this guy. So I'm going to rewrite the first two equations and figure out how to get rid of this 2x over here. Well, I've got an x right above. I could add them together, but I'll get 3x. But if I multiply this by -2, then I'd have -2x, and that would cancel out. So that's what I'm going to do on the side. I'm going to have -2x plus 4y minus 6z equals -18. Should be -18. Then our third equation, 2x minus 5y plus 5z equals 17. Add those together. This is gone. we get negative y minus z equals negative 1. Okay, so we're going to take this and replace that third equation. So we've got negative y minus z equals negative 1. So we're a step closer to our step formation. Now we want to get rid of this negative y. It looks like if we add these two equations together, the y's would cancel. So I'm going to rewrite the equations that I'm keeping. And on the side, I'm going to eliminate the y. So y is gone. We've got 2z equals 4. So that new equation goes here. 2z equals 4. Now notice we have this stair formation going on over here. Now we can back substitute like we did in the previous problem. So first of all, we know that z must be equal to 2, because if 2z is 4, z equals 2. Y plus 3 times 2 equals 5. So y equals negative 1. And now we go up to our first equation. We've got x minus 2y plus 3z equals 9. So x must be equal to 1. Then we write our solution. We have 1, negative 1, 2. So here's our summary for 3 variable systems. You need to first rewrite your system so that it's in that stair formation. You'll be multiplying by constants and adding equations, just like we learned with elimination when we had just 2 variable systems. Now, you can do this in any order. I showed you the order that I prefer, but it's entirely up to you whether you want to follow that or not. After you're in your stair formation, you're going to back substitute to solve for your variable, and don't forget to write your solution as x, y, and z.